This stone citadel of the Inca civilization was built high in the Andes Mountains around 1450 AD, but was suddenly and mysteriously abandoned roughly a century later. Mainstream scholars contend the construction of Machu Picchu was led by Emperor Pachacutec.
What if the world's most famous ruin isn't a ruin at all? High in the Andes, Machu Picchu is usually explained as a brilliant farming city built by the Inca. But when engineers examined the hidden layers beneath its terraces, the numbers revealed something strange. The drainage system could handle the flow of a small river, far more water than rainfall here could ever produce, which raises an uncomfortable question. If this system wasn't built for rain, what exactly was it built to control? But Machu Picchu mystery.
French engineer David Crespi was vacationing in Machu Picchu in 2010 when he discovered that at the bottom of one of the main buildings, there seemed to be a doorway purposely sealed up with rocks.
Let us start where everyone starts, with admiration. Machu Picchu sits at nearly 2,400 meters above sea level, wedged onto a narrow ridge between two mountain peaks in the Peruvian Andes. It is, by any rational engineering standard, one of the worst locations on the planet to build a city. The slopes are impossibly steep, the bedrock is fractured and unstable, and the rain is relentless. So nearly 2,000 millimeters of rainfall hammers this site every year, enough to turn any exposed hillside into a torrent of mud and trigger catastrophic landslides that could erase everything in their path. Yet Machu Picchu endures. Not just survive, endures. 5 centuries of storms, earthquakes, and tropical downpours, and the place stands as though it were finished yesterday. The walls are still plumb. The terraces still hold. And the drainage channels still carry water exactly where they are supposed to carry it. Surrounding mountains have crumbled. Neighboring ridges have been scarred by massive landslides that tore away entire faces of rock and jungle. But this one narrow saddle of land, this improbable little city perched on the edge of oblivion, remains intact. Something about this site is profoundly, almost suspiciously, resilient. And for a long time, we thought we knew why. The accepted explanation is the terrace system.
Terraces are fundamental to Machu Picchu. While some terraces would have been used for small-scale farming, their primary purpose was to hold the mountain in place while draining a huge volume of rainwater away.
More than 700 terraces wrap around the mountainside like the ribs of a giant organism. Civil engineers who have spent years studying Machu Picchu describe these terraces not as simple farming platforms, but as a comprehensive environmental control system. A full-scale intervention designed to restructure the relationship between the mountain and the water that falls on it. And the engineering behind each terrace is genuinely remarkable. To start at the top, the surface layer is rich, dark, nutrient-dense topsoil, perfect for cultivation. Beneath that lies a carefully placed layer of fine sand. Its job is to act as a filter, preventing topsoil from washing downward while still allowing water to pass through. Below the sand sits a thicker bed of gravel and pebbles, creating voids and channels that let water move laterally toward drainage outlets. And at the very bottom, as a foundation of rough stone blocks disperses pressure and directs the flow into central conduits that carry the water safely off the mountain. 4 distinct layers, 4 different materials, 4 separate engineering functions, repeated with almost industrial precision across the entire complex. Not once, not a dozen times, over 700 times. Every terrace is built to the same specification. Every layer is placed in the same order, the same thickness ratios, the same material choices, the same drainage geometry. This is not gardening. This is manufacturing. Each terrace is essentially a mass-produced, multi-stage water filtration unit, and the labor required to execute this design is almost incomprehensible. Extracting, transporting, and carefully layering millions of tons of 4 distinct materials on a near-vertical mountainside demanded a workforce of staggering size and an organizational capacity that rivals anything in the modern industrial world. Why, every stone had to be carried, every load of gravel had to be hauled up slopes so steep that simply walking them leaves modern visitors gasping for air. The sand had to come from somewhere, the topsoil had to come from somewhere. None of it was there naturally. All of it was placed by hand, by human beings who understood exactly what they were building and exactly why each layer mattered. And the story we have told ourselves about why this exists is wonderfully simple. The Inca needed to farm steep slopes. Rain threatened to wash their crops away, so they built an ingenious drainage system to protect their gardens and prevent landslides. Problem solved. A perfect answer to a straightforward question. A story so clean, so complete, that it has been printed in textbooks, repeated in documentaries, and celebrated in classrooms for generations. But here is the thing about perfect stories. They tend to discourage the exact kind of scrutiny that reveals the truth. And the truth, when it finally arrives, does not arrive gently. Hidden River.
Inca were building bridges that were 150 feet long. When the Spanish first arrived in South America, they called them the devil's work and were so scared to cross them.
There is a principle in engineering that acts like a diagnostic tool. It is elegantly simple. Design should match purpose. You build a bridge strong enough to carry the loads it will face. No more, no less. Anything beyond that is waste. Anything below is a failure. A responsible engineer designs for the expected conditions, adds a reasonable safety margin, and stops. That is how rational engineering works. That is how it has always worked. When an engineer looks at a system and finds that its capacity wildly exceeds the demands placed upon it, that mismatch is not a sign of generous caution or admirable foresight. That is a red flag, a bright, screaming red flag. It means the system was designed for a different problem than the one you think it solves. It means somebody understood something about this site that you do not. Now apply that principle to Machu Picchu. Thanks to the multi-layered porous structure of each terrace, every square meter of surface can drain an enormous volume of water in a remarkably short period of time. Scale that rate across 700 terraces, across the total surface area of the complex, and you arrive at the maximum drainage capacity of the entire system. The figure is astonishing. When you calculate the full throughput, the drainage machine of Machu Picchu can handle a volume of water equivalent to the flow of a small river. Now hold that number in your mind and compare it to the supposed source of that water: rainfall. Even during the most violent storms ever recorded in the Andes, the kind of extreme weather events that strike only a handful of times per century, the volume of rainwater hitting Machu Picchu accounts for only a fraction of what the system is built to process. Not a modest fraction, a dramatic one. We are not talking about a system with a comfortable safety margin. We are talking about a system engineered for an order of magnitude more water than the sky could ever deliver. Think about what that means. Imagine discovering an industrial-grade exhaust ventilation system installed on the roof of a small suburban house. Massive ducts, commercial-grade fans, the kind of setup you would find in a factory or a chemical plant. You would not look at that system and say the homeowner was just being cautious about kitchen steam. You would immediately understand that this system was never built for cooking fumes. It exists to handle a completely different kind of output, something far more powerful, originating from somewhere inside the building. The mismatch between the tool and the supposed task would tell you everything you need to know. Something else is going on here, something nobody told you about. And the same logic applies to Machu Picchu. A drainage system capable of handling the flow of a small river was not built to manage occasional rainstorms. It was built because somewhere, somehow, there is a small river. But when you look around the site, scan the slopes, gaze upward at the peaks, no river is visible. No stream crashes down the mountainside. No waterfall pours from the cliffs above. The surface is quiet. So where is the water coming from? Where is this invisible river hiding? Because the system is telling us in the clearest possible engineering language that a river exists. The capacity is there. The infrastructure is there. The precision is there. Everything about this system screams that it was built to handle an enormous continuous flow of water. The only thing missing is the source, and that absence, that gap between what the machine can do and what we think it needs to do, is the most important clue Machu Picchu has ever offered us. This is the moment the comfortable story collapses. The agricultural narrative cannot account for the capacity of its own infrastructure. The drainage system is not overbuilt. It is not the product of excessive caution or ritualistic excess. It is precisely engineered. Precisely. Every layer, every channel, every outlet was calculated with a specific volume in mind, which means it was precisely engineered for something we have not yet identified. A volume of water that does not come from above.
Reed beds are being planted and water tanks built to prevent the water from evaporating or draining away.
A volume that is constant, relentless, and enormous. A volume that has nothing to do with weather patterns or seasonal rains or once-in-a-century storms. It comes from below. And that single realization, that short, quiet sentence, changes everything about what Machu Picchu is and why it exists. The invisible river. For years, geologists have noted something remarkable about Machu Picchu's location. The site sits directly on top of a network of geological fault lines. Deep fractures in the Earth's crust, where rock plates grind and shift against one another. These are not minor surface cracks. These are deep, structural wounds in the mountain itself, some extending hundreds of meters into the bedrock, forming an interconnected web of fractures that would make any modern construction company walk away from the project without a second glance. The traditional interpretation of this fact has always leaned toward mysticism. The Inca, we are told, chose this seismically dangerous spot for spiritual or symbolic reasons, perhaps to be closer to their gods, perhaps to demonstrate dominion over the forces of nature. A poetic explanation, a romantic one, and, as it turns out, almost certainly wrong. But shift the lens. Stop seeing those faults as earthquake hazards and start seeing them as plumbing. Because that is exactly what they are. Geological faults are not just cracks. They are conduits, highways for groundwater movement. I think of them as a vast underground river system, branching and converging through the bedrock like veins through a body. The massive rainfall that drenches the surrounding peaks, nearly 2 meters of water every single year, does not simply run off the surface and disappear into streams. A significant portion of it percolates deep into the earth, seeping through porous rock layer by layer, converging within this vast network of fractures, and accumulating in underground reservoirs that have no outlet, building and building with nowhere to go. And as it accumulates, it generates immense hydrostatic pressure from below, pressing upward against the underside of the mountain, constantly striving to force its way through the bedrock, to pry the rock apart from the inside like water freezing in a crack and splitting it open. Slowly, relentlessly, without pause. This is the invisible river. It does not fall from the sky. It rises from the fractured heart of the mountain itself, a relentless, pressurized upwelling of groundwater that never stops, never pauses, never takes a season off. And the location of Machu Picchu, that supposedly reckless, mystically motivated choice, suddenly transforms into something entirely different, an astonishingly deliberate engineering decision. The Inca did not stumble onto this spot by accident. They did not pick it for its views or its proximity to the heavens. They chose it because this was the point of maximum danger. This was where the invisible river pressed hardest against the mountain structure. This was the wound that needed treatment, and they brought their most advanced technology to the exact place where it was needed most. Think of it this way. They built a gigantic water treatment plant directly over the source of the leak. Geological surgery.
Machu Picchu was abandoned when the Inca Empire was conquered by the Spaniards in the 16th century. Today, many of the rare treasures found are studied, restored, and preserved at a museum at the site.
Once you accept this framework, every detail of Machu Picchu's construction snaps into a new and unsettling clarity. The terraces were never primarily about farming. They are passive filters and pressure regulators engineered to continuously relieve the internal hydraulic forces threatening to destabilize the mountain. The multiple layers of stone, gravel, sand, and soil are not designed to catch rainwater falling from above. They are designed to intercept pressurized groundwater pushing upward from below to capture it. I slow it, channel it, and release it safely before it can accumulate enough force to trigger a catastrophic failure. The subsurface drainage channels, the precisely engineered inlet and outlet mechanisms, the deep foundations that extend far below the visible structures, all of these components were calculated to regulate pore pressure within the soil and bedrock. Pore pressure, the hydraulic force trapped within the microscopic spaces between soil particles and rock fractures, it is one of the most dangerous forces in geology. It is invisible. It is silent. It builds gradually over weeks or months, giving no warning, no sign, no tremor. And when it crosses a critical threshold, the consequences are instantaneous and catastrophic. It can liquefy entire hillsides in seconds. It can send millions of tons of earth cascading downslope faster than a person can run. It is the hidden trigger behind some of the most devastating landslides in recorded history. Entire villages have been buried, entire valleys reshaped overnight, all because of a force you cannot see, cannot hear, and cannot feel until the moment the ground disappears from under your feet. And the Inca understood this. Not in the abstract, theoretical way a modern geologist might discuss it in a lecture hall, pointing at equations on a whiteboard while sipping coffee. They understood it in the most practical, life-or-death way imaginable. And they understood it because they lived on these mountains. They watched slopes fail. They saw villages vanish overnight. They felt the ground tremble beneath their feet and learned, generation after generation, through catastrophic trial and brutal error, what water does to rock when you give it enough time and enough pressure. They understood it well enough to build a machine that counteracts it, continuously, automatically, without any human intervention required. No, the machine so robust that it would outlast the civilization that designed it by centuries and still not miss a single day of operation. It is estimated that up to 60% of the total construction of Machu Picchu lies underground, invisible to visitors, invisible even to most researchers until detailed surveys revealed the full extent of the subterranean infrastructure. 60%. More than half of this legendary city exists beneath the surface, doing work that nobody sees. So every photograph you have ever seen of Machu Picchu shows you less than half the story. The iconic postcard view, the terraces catching morning light, the stone buildings framed against misty peaks, all of that is just the tip. The real Machu Picchu, the working Machu Picchu, lives in the dark, below the surface, below the tourists, below the llamas, silently managing forces that would horrify any modern geotechnical engineer. That number alone should have rewritten the textbooks decades ago. You do not bury 60% of your construction effort underground if you are building a farm. You do not engineer deep foundations, layered drainage systems, and pressure relief mechanisms on this scale to grow corn. You build that kind of infrastructure when you are fighting a war against the mountain itself. And that is precisely what the Inca were doing. They were not farming. They were performing ongoing geological surgery, steadily, methodically, so relentlessly extracting the pressure from a mountain that was slowly dying from the inside, a mountain that, without their intervention, would have collapsed centuries ago in a cataclysmic landslide that would have erased every trace of their work. Consider the parallel with the Netherlands. Dutch engineers have spent centuries building dikes and levees to hold back the sea, to prevent the ocean from reclaiming the low-lying land their civilization depends on. It is one of the great engineering stories of human history. The Netherlands exists because human beings refused to accept geography as destiny and built machines powerful enough to argue with the ocean. But the Inca did something arguably more extraordinary. They built an inverted dike. Not a wall to keep water out, but a machine to draw water up and away, to resist an ocean that surged not from the horizon, but from directly beneath their feet. The Dutch fought the sea, and the Inca fought the mountain. And in many ways, the Inca's battle was harder because their enemy was invisible. You cannot see groundwater pressure. You cannot watch it rise. You cannot point at it and rally your people against a visible threat. You can only understand it through observation, calculation, and an almost supernatural intuition about how water behaves inside solid rock. The fact that the Inca possessed this understanding, and possessed it deeply enough to engineer a solution that has outlasted every modern skyscraper on the planet, is something that should fundamentally alter how we think about this civilization. The machine still runs. Now look at Machu Picchu one more time. Everything is exactly where it has always been. The same stone walls, the same curving terraces, the same ancient paths winding between structures that have stood since before Columbus crossed the Atlantic. The tourists still arrive by the thousands, cameras ready, breath taken away by the same postcard view that has graced 1 million screensavers. On the surface, nothing has changed. The llamas still graze. The clouds still roll through the valley below like slow rivers of white cotton. The morning light still catches the stone at that perfect golden angle. It is still beautiful. It is still breathtaking. It is still everything you imagined it would be. But in your mind, everything has shifted. You no longer see a city. You see the outer shell of a machine. The gentle murmur of water flowing through the stone channels is no longer the peaceful soundtrack of a royal garden. It is the sound of an active cooling system, the subtle hiss of pressure relief valves performing their essential function. Every drop that escapes those channels carries proof that hydrostatic forces have been successfully drawn away from the mountain's core. The lush green surfaces of the terraces are no longer fields. They are the outer casing, the protective skin stretched over a vast, intricate geological processing plant that operates in silence deep below. The reassuring firmness you feel beneath your feet when you walk those paths is not the natural solidity of undisturbed earth. It is engineered for stability, artificial equilibrium, a balance maintained not by nature, but by invisible technology that has been running without interruption for more than 500 years. 500 years. Think about that. We struggle to keep a smartphone functional for 3. We celebrate bridges that last a century. We marvel at Roman aqueducts that survived 2 millennia, but eventually crumbled into picturesque disrepair. Modern infrastructure requires constant maintenance. Roads need repaving. Dams need inspecting. Pipelines need monitoring. We pour billions of dollars every year into simply keeping our systems from falling apart. And here is a machine, a hydraulic pressure management system of extraordinary complexity that has been operating continuously, with no maintenance, no updates, no replacement parts, no human oversight whatsoever since before the fall of the Inca Empire, through the Spanish conquest when the builders themselves were destroyed, through colonial neglect when the jungle swallowed the site whole, through centuries of tropical storms, earthquakes, and total abandonment when not a single living soul knew or cared that it existed. It kept working. It is still working. That is not architecture. That is not agriculture. That is engineering on a level that demands a fundamental reassessment of what the Inca were capable of achieving. For centuries, we have stood before Machu Picchu and called it a ruin. We admired the stonework, photographed the terraces, and believed we were looking at the quiet remains of the Inca civilization. But perhaps we misunderstood the silence. Perhaps it was never the silence of abandonment at all. Perhaps it was the silence of a system working perfectly, intercepting water, releasing pressure, holding an entire mountain together while the centuries passed overhead. If that possibility is even partly true, then Machu Picchu isn't just a monument to the past. It is evidence that ancient engineers solved problems so large and so elegantly that their solutions continued operating long after their civilization disappeared. And that raises a far more unsettling question. If one ancient site can hide a machine in plain sight for 500 years, how many others are still out there, quietly doing the jobs they were built for, while we walk past them believing they are only ruins?